Welcome, ladies and gentlemen, to the Maxon booth here at NAB 2022. So happy to see everyone. I am accompanied by one of the legends and icons of our community, Chris Schmidt, the Rocket Lasso himself. He's going to be showcasing some amazing things. For those of you who have not already, jump into 3dmotionshow.com, hit sign up. We're giving away thousands of dollars of prizes, and we can keep you informed of great shows like this. So Chris has so many great things. I can't take up any more time. I'm going to let him take it from here. Chris, it's great to see you. Thank you again. Chris Schmidt, everyone. Big round of applause.
Hello, everybody. I'm Chris Schmidt. I recently just released the What's New in S26 video, and I promised that I'd be going deeper into some of the new simulation stuff today, and that's what we're here to do. We're going to be talking all about cloth and rope. So, I am from my company, Rocket Lasso, and there we make plugins, and we do lots of live streams. Every week I do a 2-hour live stream where I just answer questions live from the audience, and I'm going to be presenting from the booth again on Wednesday, where I will be just doing the whole show, taking questions from the audience. So if you've got any questions, especially about the new version, come, and I'll just be taking them straight from the audience. And then we also do tutorials. So if you're not already following Rocket Lasso, you should totally come and check us out. A couple of quick announcements. First of all, HalfRes 2022. We have the date. It's set up. If you don't know what HalfRes is, it's a one-day conference that we run in Chicago. And it's going to be exciting this year. We're going as big as we ever have. We're going to have presenters and speakers and a panel. And it's just a one-night party, a bunch of motion graphics people talking 3D, doing games, prizes, giveaways. It's really fun. So you should head on over to rocketlasso.com. Save the date. It's going to be on September 9th. It's a Friday this year, which is a big thing. Join the newsletter. We'll be releasing the tickets very soon. And then there's an NAB sale right now. We make plugins, so I've got Ricochet and Slicer and Recall and Mesh to Spline, and currently all of those are on sale. So you can head on over to gumroad.com/rocketlasso, use code NAB2022, and get 25% off all of our tools. So, and that's this week only. Anyway, let's get to the presentation proper, where we're going to be making connections with S26's new dynamics. Now, I've got probably way too many projects here, so we're going to pick and choose what we're going to be playing with here. So to begin with, let's start talking about the new cloth. Closing this up. Okay, we're going to start out basic. Pretty much the first thing you do in any simulation system. We've got a sphere here, and we got plane. It's going to be a blanket. So if I right-click on the sphere, I can go to the new simulation tags, and you're going to see we've got, well, they look different than they did in 25. And you might be like, well, where's like the rigid body? Where's the old collider and everything? Well, that has moved up to the bullet tags, because that's based on the bullet simulation system. But now we've got the all-new one. And in spite of this being, say, named cloth, and then we had the old spline hair dynamics, these are completely rewritten. They're completely new simulations behind the scenes. So there'll be some similar parameters, but all the math is completely different. So let's begin by making the sphere into a collider and making the plane into a cloth. So we just start out like that. We hit play, and it's set to GPU right now. It's important to actually mention that there are two modes. I'm going to hit Control-D, and under our simulation menu, you'll see that we can run this on the GPU and the CPU. So depending on your machine, one will be faster or the other will be faster. The CPU is typically going to be faster, but what has to happen is it kind of has to send all the information over to the CPU, or I'm sorry, the GPU, and then it'll kick in and run nice and fast. So you'll see that little delay as it sends it over, and then it'll start running really quick. So with that as our start, let's look at a couple of the basic settings. So clicking on the cloth tag, you can see we've got bendiness. So let's crank that up. I'll put it up to, say, 5, and you can see it bends a little bit more. Let's jump it up to 55, and you'll see it bends even more. Then we've got our stretchiness, pretty straightforward. We can enable that to relax a little bit more. These two work in conjunction with each other really well, and you can start pushing that like really, really far while it start drooping way down. I'm going to put it back to, I kind of like 55 and 15 is a good level for this mesh density. And the mesh density is actually a really important part of this. What's happening is kind of little mathematical springs are being created in between every single polygon that are telling it to stay a certain distance away and to only be able to bend a certain amount. So the more polygons you have, the more it will bend. You can imagine if I grab this plane and drop it way down to say just 5 and 5, very few polygons. So even though I said that this is pretty bendy, you can see that it's not going to bend all that much because there's not that many polygons. If we put this back to even some relatively small number, you see it's going to be very stiff. We drop this down to 0, it's let it come back again. You'll see it's almost a rigid body because there's very little for it to bend. But even with 0 bendiness, if I start subdividing this a lot more, so let's go and jump this to say 44, 44. So we said 0 bendiness, but you're going to see that it still bends quite a bit because there's just so many polygons. If each one is just bending like 0.1%, that adds up as they go. So mesh density, very important. And then the way that the polygons are set up, actually, another thing to mention is we've got these quad diagonals, and that's stopping a polygon from twisting sideways. Now, currently it's set to single. You can actually kind of make everything stiffer if you set it to double, so keep that in mind. If I apply, actually, let me put it back to our original 22 by 22 and hit play, and you're going to see that it can be stiffer overall, and I do like turning that on. But then you can drop this down to none, and at none, it's not worried about them squishing. It's like the old shear in soft body. So keep that in mind, important to turn on when it is appropriate for what you're building. Next up is, depending on the way you subdivide this, you can get very different deformations as well. So let's put this back to, let's do the 25 and 15, and look at the way it looks when it bends right now. You see we're getting pretty good wrinkles. It's falling over pretty well. But we can start modifying this, and what I've been enjoying doing a lot lately is using the capsules. So the capsules are entirely node-based. They're node-based tools, but we can now bring them into the object manager, and there's more of them now than ever. So if I go over to nodes, go to the list view, I'll shrink this down, click on our geometry modifiers, you're going to see a giant list of parametric ways of manipulating your object. And we got a couple cool new ones. To start out with, I would like to grab a parametric triangulate. I'll drop that as a child, and you see the mesh gets triangulated, and I didn't make it editable. So when I hit play now, it's a triangulated mesh, and it's going to, you see on the angle where we've got the flow direction that the triangulation happened, it's bending a lot more. But now we've got some of the new modeling tools, and one of them is the poke polygons, and here's a really good use case for it. If I grab the poke polygons and drop it in, it's kind of like a super triangulate where every polygon's kind of crisscrossing each other now. So we've got all these additional directions that it can bend. So only by doing that change, you can see how much more it's bending over and how many more wrinkles we're getting, how they really fill up that space. Okay, let's jump to the next file. And, okay, that's a reminder. Okay, so let us talk a little bit about the new Z Remesher to set up for the next bit of cloth. So here's your standard text, and it's just a text object. It's nice and it's got a lot of depth. I would like to feed this into the volume builder, holding down Alt so it becomes a parent of it automatically, and holding down Alt again to make the volume mesher. You can see we've got this nice geometry going. But if we wanted it to be a little sharper on there, of course you've got to grab your voxel size and drop it down. Maybe you want it sharper still, so we'd have to drop it down. We start getting to a mesh density that starts getting really difficult to run a simulation on. So I'm going to put this back to something sort of in the middle there. And we've got a new algorithm inside of the Remesher. If I go inside of this remesh, by default, it's set to the new Z Remesher, which is an algorithm from ZBrush. And it does an amazing job of fixing your topography. Like, it's so quick, so automatic. It's worked on everything I've wanted it to do. We can grab it. You can see right now, look at the mesh flow that we get now. Look how it's following these curves. Then we can change our mesh density, drop it down to 50%. And now, once again, perfectly following the shape. Nice, clean, even polygons. And then we've got adaptiveness, which is pretty powerful. Typically, you're probably going to want to have a lot of adaptiveness. If I pull it up, you're going to see that these flat areas, like there's not as many polygons, but on these corners where it's more important, you see more polygons. But if I'm running simulations, it's always good to have your polygons be as similar size as possible. So I'll drop the adaptiveness down to 0, and now you'll see that all of the polygons, even as they follow this curve, are trying to be as even sized as possible. So now that we've got a lower poly object, yeah, and I'll leave that at 50. Let me right-click on it, simulation, and go to cloth. And let's throw a nice material on there. Okay, so hitting play with this all at the default settings, we can see that it's just going to, let's also make the ground a collider. Simulation collider. So we hit play, send it to the GPU, falls over, squishes, bouncing around really nice, like not passing through itself. Like, wow. It looks really good right out of the gate. We got a bunch of different settings to play with here, though. So, of course, we already talked about the bendiness. When we crank that up a bunch, we can make it a little bit a little bit more stretchy. You see it falls into a really nice pile there. But now let's move into some additional settings like balloon. If we go into balloon, we can now apply pressure to the inside. Now this needs to be a volume. It needs to be something that holds water. Otherwise, it can't maintain a pressure. So turning this on, you'll see we have something called overpressure. And right now it's set to 1, so it's the same inside and out. So it's going to try and maintain its current volume. So without changing anything, if I hit play, you see it's squishing to the ground, but it looks like it was inflated. Very important thing when it comes to the setting. There's something called expansion time. And what that's going to do is transition into that number over, it's going to take 30 frames for it to get to a pressure of 1. So that means if I were to set this pressure up to something higher, let's jump this up to 5, instead of it instantly jumping to it, it transitions into it, which is really good. If you played with rest length in soft bodies, that you always had to keyframe it, but now you don't have to keyframe that. We can just say expansion time. So set to 5, it'll take 30 seconds, but now you're going to see it inflates up over the course of 30 frames. And then we could do the opposite. Let's go to 0.2. And now it's actually pulling air out from the system. And maybe, So now, the air gets pulled out, and then we can reinflate it, and slowly over time, it'll reinflate because of the expansion time. So balloon, really fun to play with, very intuitive. Jump this back, and let's make this not quite as bendy, and talk a little bit about the plastic deformation. I'm going to keep it simple. If we turn on both the bend and the stretch, I'm going to say if you bend even just a little bit, and if you stretch even just a little bit, just 101%, then it will remember that deformation. So, in fact, let's try and make that not bendy at all and see what happens when I drop it. And you can see it squishes, and instantly it's kind of like wants to maintain this current shape. And if I then inflate it, you see how it's not going back to that natural balloon shape anymore. It's going to what it crushed into. Alrighty, let's move into continuing this concept over here. So, almost exact same setup here. We've got a collider set up on this torus. We've got another cloth on this ring, and then some cloth set up on this text. Exact same setup through the volume builder, mesher, and then remesher. So, with all of this in mind, I should be able to hit play. And it's going to fall, and it's hanging there, and you can see how each is bending. It's doing a great job here, running in real time. Let us push this a bit further using one of my favorite features inside of cloth, and that is the new tearing. Now, we had tearing in the old cloth, but there was definitely some limitations that made it frustrating to use. The main one being when something would tear, the polygons on either side of the tear would disappear. And so you always had you'd have to crank up your mesh density so you could kind of hide the fact that that was disappearing. Well, now I can just turn that on. Let's see how it looks here. Hit play. You're going to see we got a rip instantly on it. And let's hit play and let that keep on moving around. Let's weaken this a bit, 120. And you can see a tear, and look at, oh, that's so good. Look at the way this is tearing apart. The polygons are not disappearing. The seam travels along, ripping as it goes. So there's two settings here. There's the tear pass, so if it stretches beyond both the rotation and the stretch, if it goes beyond that point, it will break. We've got the tear guiding, and if we put this to 0, it's going to say, I want the tear to keep heading in the same direction, like maintain a 0 angle. So that's going to result in straighter lines on the tear. Yeah, you see a nice straight cut across that. If we put this up to 90, which is the highest it can go, it's going to be trying to make harsher turns as it tears. And you see how much messier of a tear that was. And this is just with this being like perfectly rectangular polygons. If this was triangulated or you had some sort of a crazy mesh, you'd be able to get crazier looking tears. Very nice on top of this. We could throw this entire thing directly into a subdivision surface, hit NA, and as that runs, the tears will run in there where it gets nice and smoothed out and rounded. So a lot of opportunities directly with that. Something important to mention here is both the rope and the cloth, these tags are deformer tags. So if you had been using soft bodies for a while, you know that you might make a mistake sometime where suddenly the mesh would get baked down into the shape you didn't want it to be, and even if you hit undo a bunch of times, it would still be gone. You couldn't bring it back. But this is a deformer, meaning the original mesh is never changed. It just gets deformed. So essentially, that could never happen. And also, it was always really dangerous in the bullet system to change anything, not at the time of 0, because that type of thing might break. I haven't run into that at all here. I've been making changes as it's playing, and it'll just reset the simulation at that new time. So very nice there. Let's combine a couple of the things that we've just been looking at. So we've got the tearing. I'm going to turn that off. Let's go back to the balloon. And I would like this to inflate again, but we're going to go pretty extreme. I'm going to say I want to inflate up to 8. If I have play, you're going to see it's going to look super crazy as it inflates. And I'm going to say I want this to happen pretty quickly. I'm going to have this happen over maybe the course of 5 frames. So very quickly, you see it kind of shoots out really quick. So now if we combine that with the tearing, remember, tearing can only happen while it's a volume. So it should be pretty mild right now, but when I hit play here, you see, actually, no, pretty extreme, actually. Let's put this back to 0. Oh, it's not on the default. If I go back to 150, we should see it popped, and only popped in a couple little spots. And as soon as there's a hole, it couldn't hold the pressure anymore. But instantly, I was able to make this tear. So depending on how you set up your tear past value and how quickly you expand it to a large size, you can get different looks. So look at how it tore in that one. Now I'm just going to speed it up. It's going to expand in a slightly quicker time. And now when we run, way more tearing, and now let's drop that down to 2. So I didn't even change the tear past value, but when I hit play in there, that's going to super explode, and we get this super shredded mesh, and you see it's still continuing to tear as it goes. It's so quick, it's so intuitive. Just being able to tear things, inflate things, with just a couple of clicks. This is such an amazing addition to the Cinema 4D simulation systems. Let's jump into the next file. We're going to actually skip over this one. I've got more interesting ones I want to make sure we get to. Okay, Vertex Map. This one's really cool, really powerful. Okay, here's a text object, kind of a default there. I'm going to make a couple changes. I want this to be completely flat, so I'm going to get rid of all the depth. And what's cool in the text object, if you make it flat, it's now just like the front cap. It's not like an invisible squish down side. It's just the front cap. And then I want to, it's set to subdivided, and I said that on this, essentially the spline that's making this, every 5 steps it's making a point. So now that means I can go into caps and change the cap from this nice clean Engon to a Delaunay. So now it's getting subdivided in a nice kind of random way, so that's why I built it like this. And we can say the density should be cranked up all the way, so you can see a nice even triangular polygon count. I put it into a connect so I can make that editable. We don't need any of these tags, so I'll delete those. And that's been baked down to a single object. Adding a new simulation cloth, let's take a look at some of the dressing features. So I'll say I want the dresser. Let's go to points. Look at this from the front, and let's make a rectangular selection. I'll select all of these top points. Select all of these top points. And let's say fix, just like the old cloth. So back to object mode so we can see it, and hit play. And the simulation goes. You can see they all tilt over, and it's working perfectly fine. I was able to belt those just to where they are globally. So now, let's see if we can get this to tear a little bit. You can see the E's are bending the most. So let's go into the tag, back to tearing, activate that, and see if anything happens. Nothing there, so let's lower this down to 120. Still not quite anything. Oh, there, if I reset it, you can see that E started to tear just a little bit. So that's a good threshold. I like where that's at. But now, let's put a vertex map on top of this. So I'll go to point mode, selection, set vertex weight, and just feed whatever we want. So that's a nice empty one. It's all set to 0. And this vertex map is assigning information to every single point, saying, are you a 1 or a 0% or a 100% or anywhere in between? So now we've got that. We can control it via fields, and I love fields. They're so good. Let's clear out fields so it's super empty and create a spherical field. T for scale. I want to make it nice and small. And we'll create a couple of keyframes. So I'd like this to begin over here. So I'll go to object mode, grab our spherical text, coordinates, and keyframe it at this time. I'll hit play, and just 1, 2, 3. Yep, right around there seems good. And I'll animate it over to this side. Keyframe. Go forward just a tiny bit, and scoot it over to here. Keyframe again, hit play, and right around there. That should be all the keyframes I need to do. And you can see that what I've set up is this to pass through every one of the letters at a different time. So if I play, you can see it's going to flash yellow only where that selection is, just for a split second. So we want it to remember where that is, but not only remember where it is, but grow from that point. So selecting our vertex map, I will create a modifier layer called freeze, and I would like the freeze to grow And I think the defaults just are working really well on this particular scene. So it's going to grow a radius of 10. So if any point's within 10, it'll grow to it, and it's going to give it 100% strength. So having done that, I'll set this to add. So it's going to see what's below it, and it should automatically update. And if we hit play, hopefully we'll see as this passes through, it's growing after it touches each one. Now it's going a little bit quick right now. I think I'll set it to 50%, but we'll see how that affects things as we go. So that should just make this grow a little bit slower. So now that we've got that working, we can go back into our cloth, twirl down our tear past value, and feed this vertex map in. An important thing to note when it comes to feeding vertex maps in, and by the way, you can feed a vertex map into the mass, thickness, like all of these, you can feed it everywhere. So there's going to be a lot of cool, crazy experiments we're going to be able to do in the future using this. Anyway, I've now fed it into the tear value, and now it wants to know what the minimum is. So I'm going to say when it gets infected, it'll be 101. So essentially, normally it's 120, but now it'll change to 101 as it goes. Now this might be pretty subtle, so let's check it out. I'm going to hit play, and it's going to travel through. And let me select the vertex map so we can actually see what it's doing. So you can see how it's growing, and that's going to make it a little bit weaker as it goes. And yeah, you see a tear randomly happen in some different spots. So that's with this value set the way it is, where things are kind of randomly breaking. Now, an important thing to note is this isn't breaking where it's at 100%. It's not breaking where it's yellow. It's breaking at the highest point of contrast between red and yellow. So it's the points of contrast that matter. So along those lines, what I'm thinking is let's drop this to 100. So even if it's at, essentially anywhere, if it starts getting affected, it will begin to tear it. So now as I hit play, as it grows through, you can see that it's just shredding itself as the growth happens. As long as it can tear anywhere, it's going to continue growing and tearing the entire thing apart. We could keep going and going on just this particular setup where we could add on all sorts of modifiers and slow this down, put in a random effector so it's traveling in different passes throughout the entire thing. But we got more things to cover. So that's just a nice little overview of being able to feed in a vertex map. Okay, we are going to move into the rope now. So rope, really nice as well. It's the same system that's running in cloth. It's a new particle-based dynamic system. So we're going to start out with noodles. Noodles is just a good way of doing any dynamic simulation. So I got a sphere here, set this hemisphere. I'm going to throw in this taper to make it a little bit wider. Use one of those capsules to solidify it, and then bevel it. And there you go, nice little quick procedural bowl. Hide that taper, we don't need that. And let's make our first noodle, which will just be my old friend, the Helix spline, where we can turn it into a straight spline by saying 0 radius, and now we get a straight line. Tell it to aim upward. I'll set this to, let's do 800, and there's exactly 100 points, and I'll get rid of the intermediate points. An important thing to note is the soft bodies on splines didn't used to see intermediate points, but this system does see the intermediate points, which is really good, but that also means you got to make sure that if I want exactly 100, I better make sure I'm not accidentally subdividing it with these intermediate points. So there we go. It's exactly 100 points traveling up. We'd like to see it a little bit better, so let's feed that directly into a sweep, adding in a end side, and we'll drop the radius to 1, give it 10 sides, and hit NA so we can actually see it nice and clean. And let's add on the simulation. I've already got a collider tag on the bowl. Let's add a simulation rope tag onto our noodle here, and then hit play. And immediately you're going to see it fall into the bowl, happening super crazy fast. Okay, let's make it a larger noodle. So let's jump that up to 800 and 1,000 points. So it should be going way higher up. Hit play, and we'll see it continuing to pile up into the bowl. Let's see. Let's slow that down. I'm going to go into our collision settings. We don't have a lot of time to talk about these. I just hit Control D, and here's your global simulation settings. Keep in mind your bullet settings are over here, and then we have our simulation settings. So there's a lot of settings here that I will be continuing to explore in the future. Right now, it's a little bit more art than science, as far as I can tell, where we have a lot of things that sound like they do the same thing. We have substeps. That makes sense. We've had substeps for a long time, and that's the one. I'm probably increase that up to 40. But now we've got something called iterations. We got smoothing iterations. We've got collision passes, post-collision passes, and polish iterations. And it's like, well, what does what specifically? The two most important ones are going to be your substeps and your collision passes, where that's just going to help your simulation overall, and you can keep on increasing those if you want. Keep in mind, when you change your substeps, you are changing the properties of the dynamics as well. You're essentially making them stiffer. But in any case, let's hit play. So we've increased that, and now we've got a noodle falling into the bowl really well. Let's push that further, though. Let's throw that into a cloner. In the cloner, I'll set that to radial. And let's make, I don't know, let's go way up there. So now we've got we got 67 different noodles, but you'll see that the sweep isn't seeing it. Why isn't the sweep seeing it? Well, the sweep can only see the first object that's fed in, and right now the cloner is feeding out 67 individual objects. So all we have to do is feed that directly into a connect object, and that will merge them down into one object. When in doubt, use a connect object. And just a tip, especially if you're on a slower machine, this one is not, but if you're on a slower machine, if you're generating a lot of different splines and you can get away with it, turn off your caps. When it comes to a sweep, the caps eat up a majority of the calculation time. So that should just make those run a little bit quicker. I think it's going to overfill the bowl, so I'm going to jump this back to 800 by 100. And let's go into the settings, and you can see we've got a bunch of different settings here. How bendy is it? How stretchy it is? Bounciness, friction. Let's give it a radius of 1, because that's the radius that we gave the end side to actually create the geometry. And when I hit play, you're going to see nothing happens. Unlike the soft body system, you want to put the tag onto the cloner, not the child. So now that we've done that, we hit play, send it to the GPU, and then we get a giant pile of noodles all falling in at the same time. And instant bowl, filled up. Look how fast that's running. Like, it's so much fun. One little trick you can do here that I've been enjoying is if you kind of want to get everybody likes making piles of string or rubber bands or noodles, whatever it is. But if you want to get a little action from it, we can take this and just increase the radius to 1.5. So we're suddenly popping that radius to be larger. I'm just going to hit play for a couple of frames and then pause it immediately. And then I can drop it right back down again. So now it'll continue that explosion, so like instant explosion of noodles with no forces, nothing, just like one little keyframe, you can get a nice little pop going there. Moving on. Okay, so this is just kind of doing a stress test for you. There's a bunch of different splines cloned around a torus, which has got a collider on it, and I just threw the default rope on top of these, so just a bunch of splines all kind of tangled up with each other. So let's zoom out a bit and hit play. And sending to the GPU, and they all fall, and they tangle up, and they're staying properly tangled. Anyone that's passing through another one is holding on, like, it's working so well. Now, let's rewind and tweak a couple of things. I would like to select both of those and turn on tearing. We can tear splines now. So I think if the setup is working well, these shouldn't really break too much. I should be right at the correct level. Let's see. The GPU's not liking this one too much. I am going to switch it to the CPU like I was practicing with. We'll see if it likes that a little bit better. The CPU will typically start playing a lot quicker, and in this particular scene, the CPU seems to like it better. You see a couple of them are tearing, but I'm going to go and turn on this emitter, and that's going to start shooting these spheres, which also have a collider on them. And as the spheres hit it, you see that they're getting torn wherever that collision happened. So immediately you can start to see some of the potential of this. So let's make something a little bit more practical. Probably a common thing that people have to do for client work. Let's just make a nice simple sign here. So we've got a nice little simple sign. I've got these ropes, and just to save time, these are just a couple Helix splines I made editable. They have exactly 25 points traveling up. And the important thing to note is, you see I lined this up so it's very close to a point on here. And also important to note, you don't want them perfectly touching. If this rope has like a radius of 1, you don't want that point fighting another point in the exact same spot. So give it a little bit of distance, not too much. So the sign's already dynamic, and then we've got this torus up top that we want to hang the object from. So here's our ropes. Add a simulation rope tag. And currently everything will just fall away, so we need to start connecting things. So we've got two different ways of connecting things depending on what your situation is. So first, let's belt this onto this, unrelated, it's not a dynamic object, so let's belt to it. Right-clicking, we go to simulation, and keep in mind there are two different belt tags, one for cloth, one for rope. So I would like a rope belt, and what do I want to belt to? I would like to belt to the torus above. What do we want to belt to it? Well, let's go and select some points. I've already got the top two selected. That's what I want to belt on there. So if we zoom way up and I hit set, then you're going to see it's going to jump to the closest possible surface, and it should now be connected. It's belted on there. It's a good idea to have your influence not necessarily be cranked up all the way. Like 90-90 should be good. That way it's not constantly trying to pull it and intersect it. But in certain situations, that should also work for worked fine for you. Okay, and now we add a simulation connector tag, and we're going to be talking a bunch about this in a little bit because it is amazing. Okay, so this connector tag is like super smart. It is looking for all the other simulated objects in the scene, and it is going to make connections for us. There's two modes. There's look at the same object and look at different objects. So we're in other objects right now, and something that's cool is you can click on this Update Live button, and you see that there's no connection between these right now. But because we're saying Update Live, if I start increasing this radius, once I hit the perfect length, you'll suddenly see that connection get made. It's like, oh, okay, cool. I can turn that off, and it's now remembering that connection. And that's only for immediately adjusting it. I think right now you can only do a connection at the start. But anyway, having said that, we have now connected the rope to the sign and to the torus up top. Now I've got a little turbulence in here just so we can see some motion. When I hit play, you can see the sign perfectly hanging from the rope, hanging from the object. We can go and move them around however we want. But let's rewind that and then turn on this sphere, which is a really heavy sphere, and you can see it smash it, bounce around like instant, easy sign. Two different tags connected to the objects, like just automatically working for us. So that's a nice, simple thing, probably practical in a lot of people's everyday project situations for a client. But let's go make something a little bit more fun and maybe impractical. So let's make a rope bridge. Again, I've started out with a spline exactly 1,000 long, exactly 100 points, and they are separated by 100 centimeters. Okay, I would like to make a bunch of connections. Well, let's make it dynamic to start out with. I'll say simulation, rope, and then I would like to set the points so I can just fix a point. So a quick way of selecting the points I want, I can hit Control-A, select all, UK, shrink, UI, invert, and now I've grabbed the outermost points. So if you had 1,000 splines, you could automatically grab the outer points by doing that. But anyway, I've got those outer points, I can hit set, those are now locked in, you see they turned pink, and now when I hit play, that's going to now run. The rope seems to, on this computer, it seems to like the CPU better, so I'll switch it back over there. And now you can see that we get the rope bridge. Nice, simple connection there. Now, let's start making a couple of planks going across it. And I'm going to keep this in the world of splines. So going to this top view, I'll just click on the spline pen tool, and deselect that one. I don't want to draw on the existing one. And just kind of eyeball a single one across. Hit escape, and then I'm going to hit Control or Command A, select all the points, open up our coordinate manager down here, and I would like it to be, I'm going to make it precise, so exactly 0, 0, 0, so it's a perfectly straight line, perfectly at 0, and I'd like it to be exactly 99 long, so just barely not touching the bridge, just like we talked about. So now, just to save some time, I've got a cloner set up, and I'm going to feed that spline into the cloner. The cloner is set to be 1,000 long with 100 different ropes. So I'll just turn that on, and you see a whole bunch of those cloned across. Okay, now, without even making this cloner editable, let's add a simulation rope to it, and now we want to make some connections. So right-clicking on that, I'll say simulation connector, and let's zoom up on one of these and see if we can watch. So you can see you got that little bit of gap there. So if I say, give me a live update, that was close enough to automatically connect, and you can see I got an automatic connection between every single one with a single click. If they're a little further away, I would just increase the radius. But with those now connected, let's zoom out and hit play. And now we've got all those instantly interconnected between them. Now, what you're seeing right now is those individual lines are really heavy. So let's say that those lines should have a lot less mass. So let's go and set that up where those will only weigh 0.01. So they'll still be connected, but those outer ropes are way heavier, so now it's not going to be dragged down nearly as much. So let's make this fancier still. Grab those bottom supports, duplicate them. Go to object mode, E for move, hold down shift, and I'm going to move them exactly 100 up. And now I'll copy those planks that went across, rename that to up so I don't confuse them. And this time, let's have them be rotated 90 degrees. So now it's vertical. And then back to object mode, I'll say I would like 2 of those set to 100 parts. You can see they're perfectly lined up. Back to transform, I'll say, and now offset up 50. So there we go, exactly the same setup, mirrored up to the top, except I don't want quite that many. So what I'm going to do in this instance is create a null and drop that in. And now you can see it's doing null, spline, null, spline. So I'm going to say, actually, I want 2 nulls, and then a spline, and then 2 nulls. And that's just a nice clean way of making sure that those ropes are still lined up perfectly where they would have always been, except the empty spaces are just filled up by nulls. So again, we've got, it's already a rope, it's already lightweight, but we need to make new connections from this one. So hit clear and hit create, and let's zoom up a bit just to make sure that we did indeed get the connection. And you see the little yellow line right there, so we did. So those are all now interconnected. This is the upper support, so I'm gonna just call that upper. And I'm going to select that and say it's going to be the least bendy and have the most weight. So essentially this one is going to have the most support of all of them. So we've gone and made those changes. Should be working, hit play, and all of those are instantly interconnected. We locked just those corner points and everything else is being driven by dynamics. So a lot of fun, really quick to make those connections. Love it. Let's turn those into geometry really quick. So I'll put this one in here. Again, it has to be in a connect object to see all of them. And let's drop this one in here, get a little bit of geometry there. Hit play, there we get some planks going, and I can turn the sphere on and drop it down, have it smack the bridge, boom, instant rope bridge, just ready to have fun with. So easy and fun to put together. Close that up. Okay, we have to see, how am I doing on time? Okay, we're gonna do this as quick as possible. I've got the ready-made scene, which we will jump to, but I think this is a really cool technique, so I want to at least talk about some basics. I want to interweave some ropes together so we can make a really nice looking net. So there is a spline called the segment spline, and it's a straight spline made of capsules. So I would like to drag that in and say I would like a length of exactly, is it 1,000? No, it's 500 in this file if I recall it correctly. Okay, exactly 500 long. I would like exactly 20 points, and I'm going to make it editable because we need to change that to linear and none. So now, if I select points, you can see exactly 20 points going across. Really straightforward. So what I'd like to do is make a zigzag out of this. So here's my favorite way of making a zigzag. I'm going to make a plane effector, which normally is for MoGraph stuff, but you can change an effector to deform points. Now, it's a plane effector, so pushed it up by 100. So I don't want it pushing up everywhere by 100. So let's go into the fields and feed in a step fall off. So now it's taking the index of each point and multiplying it. So the first index is 0, the last one is 1, so it's stepping from 0% all the way to 100%. So okay, nice linear line, but now we can remap that. And I like using the formula for that. Now by default we're going to get a sine wave from it, which is nice, but what I would like to do is type in, and you can find this in the help, but if you're going to remember one formula, it's this one. If you type in mod for modulo, M-O-D, and then you click bracket, and then you click ID, so that's the current ID of the point, and then semicolon 2, so I'm saying every other, and then close bracket. So just remember that, click off of it, and now instant zigzag. Now I would like it to, maybe right now it's pushing up, I'm going to say I want half up, half down. So at the very end of this, I'll say minus 0.5, and you'll see the whole thing moved down, but it didn't, the bottom points didn't move down, and that's because this field is currently clamped between 0 and 100. I'm going to say don't be clamped, and now is allowed to go down. So now this is kind of a procedural. Even if this wasn't editable, this would still be working. So it's a nice zigzag deformer. And now just because it's a plane effector, we can modify it however we like. In this case, I want it not to zigzag quite as much. And then from here, I would throw this into a cloner. We would set that to, I think, 1 by 20, and then we see get some nice zigzags traveling this direction. I want the end point to be exactly 500, so we got 20 of them in a line. But what I'd actually want is every other one to go the opposite direction. So if I duplicate that, I could then say, go back into the effector, and go to the field, and then under ID, I'll say, actually, do ID plus 1, so it's just going to offset them all by 1, and now you can see they're doing the opposite. As quick as that. So then I would take the cloner, hit R for rotate, spin it around, and now we have perfect, not intersecting, zigzagging lines traveling both directions. Now, I don't have time to go and build the entire setup if we're going to get to everything, but I would put these into a cloner, make them editable, like feed them through sweep and everything. But let's just jump to this file where I've now done that process. In the exact same way that we belted the ropes on the torus to hang the sign, I belted these to these bits of geometry. And let's turn off the sphere for a second and just take a look at a couple of these settings. So if I hit, here's a brand, I even set these to default just so we can step through. So I gave it a radius of 4. That's exactly what these have. That's the thickness of the sweep as well. So if I hit play, we should see all of them perfectly drop down, but they're trying to maintain their shape a little bit. So I'd like them to be very bendy. So I'll jump the bendiness up to like 55, and I immediately see them relax and all fall down. And then right now they have a lot of friction. Friction's up at 5. If I get rid of the friction, you see that they're kind of free to slide down. And if the radius was even smaller, I think you'd see them like sag down even more. So immediately it's like, okay, this is really nice. This is a fun setup. But let's go and kind of put those back to where I had them. Maybe a little bit of stretchiness. And let's get that, well, I'm going to leave the friction, actually I'll turn the friction up. And now let's create this sphere. So, and the sphere just has a default, I think, completely vanilla cloth tag on it. And now we hit play on that and let that fall. And it will catch the sphere. But let's make that more interesting still by going to this vibrate tag, which I slowly animated up. So we don't want it, a vibrate tag always kind of pops in. You always want it to transition in, especially in a simulation. So I will enable that vibrate tag. Hit play, and now the entire thing is going to be shaking around. And we've got a super awesome running in super real-time net catching a different dynamic object, like everything just working great there. I'm going to show you how direct this is. If I grab the rope and say that the friction, I'm going to lower the friction, maybe not even all the way down, the sphere is going to want to start pushing through there. I guess, you receive, because there's less friction, the ropes could move out of the way, the ball could push them out of the way. So like you see what a great and immediate effect that even the friction could have in a setup like this. So we've got so many cool opportunities we're going to be able to do with this stuff. Okay, moving on. Okay, so this is one that we can't, it's very, I don't have a full demo on this, but I wanted to show a little bit. So here's a basic clothing setup I've got. And we're not going to build it from scratch. Here's a couple important details we will step through. Let me temporarily disable that and hide it. Okay, so here's a character I brought in from Mixamo. And it was really important that I kind of set him to a T-pose and let him go from T-pose and then transition into the final. You don't want to be modeling clothing on a character who's already in a pose. So Mixamo character, it's just running based on being, bound to all of these different joints. If I hit play, you're going to see that it's just a character transitions in slowly, and then he starts this animation. Now, the tricky thing that you have to keep in mind if you're going to try any kind of clothing is if some geometry passes through other geometry, and you had cloth in between there, where's it supposed to go? So you would automatically be forcing it into the mesh. And right now I don't have a good workaround for that. But if you got the right animation and you got the right model, it's not passing through itself, we've got really great opportunities here. So having said that, here's a nice simple shirt. All I did was select his own polygons, extruded them out just a tiny little bit, and let's activate it. And then there's a belt tag, and the belt tag is just, pinning it to the mesh, but you see very weakly. It's allowed to move around quite a bit. So having done that, if I just hit play here, you're going to see running in real time, the shirt looks awesome. The way it's shooting up, the way it's barely overshooting down, it works really, really well. I'm very pleased with the potential for where we can go with this. Just to show you the limitation, here's a simple pair of pants. And if I enable that one, it's going to look pretty good from the front, but because of the way the character's bending over, right at his waist, it pinches, and on the back of his knees, it pinches. And so here's the problem currently. So you see it looks really good, but if I pause and zoom around, where it pinched, it forced it through the mesh. So I'm exploring ways of getting around that. But you see how well that's running, and if it wasn't for those intersections, and these are almost default settings on these, you can see that the way the cloth is behaving is really nice, and we've never had anything like that directly in cinema. So we got fun possibilities there. And just to make it a little bit weirder, let's jump over here. Here's the same skeleton, that same animation. If you didn't know, you can actually convert the joints. You can convert the skeleton into geometry. So if you don't know this is a great trick. You can middle mouse button click on an object, and it will automatically select every child at the exact same time. I use that all the time. Anyway, all the children are selected, so I could say, I want to go to character, convert, and you can say convert joints to polygon object, and now you can see that I've got a polygon object that, if I move, scoot it forward, we've got geometry. So I could go to polygon mode, select it, hit D for extrude it. So anyway, I went and did that process, and I jumped over here, and I took that skeleton, fed it through a volume, and then fed it through the Z remesher, and I ended up with this nice skeleton. It's super easy to bind a character. I'm going to middle mouse button click, selected all the joints. Also, select the skeleton, you go character and bind. That's all you got to do. That's now bound. So that will be animated, the same animation we were just seeing before. I would like this to be a collider. So that's something we can collide with, and now we're going to have an animated collider. And I'd like it to have a bunch of friction. Okay, now I've got that same character that we had from before. Here he is set up like pretty much default settings all the way across the board. But this time, the cloth tag is directly on the entire body. So we've got a tiny little skeleton and the entire original character. I'm going to leave it default from now, and let's hit play and see what we get. So yeah, instant creepy skin suit guy. We can rewind that. I'm going to try switching that to CPU, see if it likes that. A little bit smoother. Yeah, a little more consistent there. And then let's go into the cloth again, and let's set the balloon. Actually, I haven't tried inflating him. Let's see what happens if I do that. Okay, we're going to inflate him a bit. Okay, good start. Now, the one I have tried, I'm going to hide the skeleton. And let's deflate him. So I'll put it to 0.2. So now it should pull the air out. And you can see where, like, almost you can see the skeleton inside of it now. So, that's so good, so weird, so creepy. And then, let's make him a little bit creepy by putting a shirt on him. And so we'll activate that, enable. There we go. So now he's a friendly, creepy skin suit guy. And then what's great here is because now his, all of that, this geometry won't be self-intersecting anymore because it'll push each other out of the way. So I think this is actually a better setup to do clothing than the entire animated character because it won't pass through itself. So yeah, more fun. I expect to see a lot of daily renders doing that type of thing. So let's move over. Let's see, how's our time? Well, not a ton of time. I'll see if we can come back to this one. If we don't have enough time, then I'll save it for my Wednesday presentation. But something I wanted to spend just a little bit of time on is showing how a couple of our plugins are working so awesome with these new systems. I had no idea that this new simulation was coming out, and the way it ties in with our tools is really cool. So let me show you a quick demo of a Rocket Lasso plugin. And as I mentioned, these are all on sale right now. So here's a similar setup we were seeing already. I fed some text into a volume, into a remesh, nice even polygon count everywhere. So we have a plugin under extensions that I made called Ricochet. And what Ricochet does is essentially it's making a spline and it's shooting a laser. But let's say that laser should be, I guess we'll go right to the advanced one just to save a little bit of time. So I'm going to put this just barely above the model. Actually, no, we got to show the good demo first. I'm going to move this in, and I'm going to say, hey, Ricochet, I want you to see an object. What object is that going to be? It's going to be this entire mesh. Instantly see it disappear. What's happened is it's trapped itself inside. So this is now a laser bouncing every time it hits the mesh. So now, you see it's a nice laser. We can do all sorts of things, like keyframe this to be bouncing through the model. But let's go and crank this up all the way. It's like, okay, that's kind of cool. You can read the letters now. But let's make that times 10. And instantly, you see, fills up almost instantly. But let's do another times 10 and fill it up that much. Like Ricochet, it's super fast. It's really cool. I have no idea how you do this stuff otherwise. You can see how dense all of these splines are. Let's pull this back to something semi-reasonable. And let's bring the object back in again, because what I'd like to do is a little bit more advanced setup inside of it. I'm going to move this just barely above the object. Inside of Ricochet, we have the ability to kind of create a shell. So there'll be an inside and an outside. So if I just turn on visualize, I'm going to say I want a shell, a surface, or I'm going to say I want a shell of 2, and whoops. That should be creating kind of it's like a little thin wall in between there, virtually creating it. So what's happened, and then I think I'd like to offset it out a little bit. So now you see it's kind of trapped on this outer wall, traveling around the entire outside of the object. I'm actually going to offset it a little bit extra so it's not intersecting anywhere. So now, yeah, we've got these bouncing around, oh, not 1.5, 2.5, please. Okay, so that's bouncing around the outside. We've got additional settings where I can say, I would like Ricochet to align to the surface more. So let's do some surface alignment. And instead of just bouncing off it like a laser off of a mirror, it's going to start aligning with it and following the curvature. So you see we start getting these nice smooth lines traveling around. So let's crank this up to, I don't know, maybe 3 times the length. And I can keep on hitting random to get different bounces until I get a really nice distribution of lines. That one looks okay to me. Okay, so we've got our a parametric ricochet. We've got parametric text set up. Let's right-click on there and add a simulation rope. And I don't even think I'm going to change any numbers here. Let's just hit play and see what happens. Oh, let's make this a collider. Okay, yeah, this remesh is a collider as well. So hit play and send it over, and instantly we got ropes completely wrapping this thing up. Let's rewind, go into ricochet, and I'm going to say I would like the spline to be subdivided. So let's say it's linear is fine. If I'm going to give it a subdivision of 5, I think it's a pretty big scene. Let's do 10 just to be safe. Big old angle. Okay, so I subdivide, there should be more points. And it was running really quickly, so why don't we double the amount, so even more lines going. Let's feed that into a sweep and a end side. And drop that again down to, let's go 10 around, radius of 1, NA to see the actual geometry. And that's a radius of 1, so we'll give the string, the rope, a radius of 1 as well. Okay, let's hit play again and see what we get. Okay, oh, look at that. Like instantly just dangling off the object. And this is pretty much all default settings. Let's crank up the bend so it can maybe sag down a little bit more. I'll push that even further, so very bendy. And let's make it a little bit stretchy as well. That's able to stretch. Let's see how far I can push the stretch. Okay, yeah, you can see it sagging down really nicely there. So yeah, absolutely wonderful way of... How would you make this otherwise? I can't even conceive of how I would attempt to build this. And you see, completely clean parametric setup. I love doing this type of thing. So where things can get a little bit even more interesting here, I want to see this a little more clearly and visually. Let's jump this even higher. Let's do more twisting around. But I would like the radius to be a little smaller, so let's drop to 0.5. Yeah, there we go. You can see that a little better. And radius 0.5. So currently, these are all just going to be dangling off the object. It's just purely from the friction of the model that's stopping them from sliding. In fact, if we said, hey, spline, have no friction, when I hit play, with any luck, those should, like, look at them just sliding off the top. So, like, really cool there. So let's leave, oh man, that's cool. Okay, so let us go and turn that off temporarily. If I right-click on any spline object, but Ricochet is doing a really good job of it, I can say Simulation Connector. Now, before, we did some connections between different objects, but now we can say, I want to look at the same object. I'm going to turn off other objects. I only want to look at the same one. And now, if we turn on Update Live, let's zoom up a bit, and now I can start increasing my search radius, and you're going to see little yellow lines interlinking all of these. So all of these have now gotten connected to each other. I don't want too many. Let's just get a couple of them going. Now remember, the friction's really low, so it should start sliding. And let's see what that does out of the gate. Let's turn off Update Live and reactivate the sweep. And we've got those connections now. So when I hit play, hopefully we should see that different splines are stuck together, and look at this nice webbing we've got now. Almost no friction, but they're still trapped because look at this like netting that we have now, zooming up. Those are all interconnected. So we could crank this way up and make tons more connections, like going really far. You can imagine making all sorts of like spider webs and nets and just going completely crazy with all of that. So taking this concept into a slightly different file. I'll just jump to the end of it. So you saw how I was bouncing around the Ricochet already inside of it. So this is that same setup with the Ricochet bouncing around inside of the text. And just to show you, here's what the text looks like. It's all separated. So having done that, let me hit play. Oh, it's almost the exact same setup, except instead of outside, we're inside. So just to be clear. Okay, turning on. Here's our rope set up. And I think we just hit play. And we'll see all of those. Oh yeah, important. I hit Control D. And under the global simulation settings, I changed gravity to 0. So they're just floating. So you can see instantly, first of all, it's really cool because you can make sure that nothing's intersecting each other. Like now, there's no intersections going. It just fills these up. So pretty cool there. But then I just make a Attractor. Let's make it from scratch, I guess. Let's go to Simulation. And all of these forces work with it, except not field force yet. So I'm looking forward to a future where that is integrated. But here's just your basic Attractor. I'm going to slow the speed way down. So that's going to be attracting, that might be too slow, but we'll have this Attractor going nice and slowly. And I'll just move it here into the middle of the 6. Now, I think by default, that should apply to everything. And now when I hit play, you can see all of these lines getting pulled let's make it even stronger. Jump it up 22, and we'll make it a little bit faster. So yeah, you can see all of these getting pulled towards this attractor. So, and, I mean, we're using my tool here, but you could just be filling this up with any spline, and you can see me interactively be able to pull this around and make things travel, fill up. You could set this to a negative value, I believe, and now it's going to push things away. So, you know, so many different possibilities. This could be a ton of tiny splines. This could be filled with cloth if we wanted it to. Again, the endless possibilities. It's another new playground. Like, we haven't had a playground like this since, like, R12 came out and we got the bullet dynamics, but now rope and cloth, like, absolutely incredible. And I think I have a minute just to show that our other tool, Mesh the Spline, can also do a similar and fun thing, where if you want to keep this parametric, and, well, here's the setup. You see I've got some very basic text here. Again, very nice and low poly intentionally this time, because I make a duplicate, and inside of a volume, if you haven't done this with volumes, it's really fun. If you create a dilate and erode, a better way of thinking of that is just kind of like inflate and deflate your geometry. So if I start increasing that geometry, you can see that I can inflate it to be larger. So now I've got a smaller mesh and a larger one. So now this outer mesh, I will feed that into another one of our tools, which is called Mesh Two Splines. Holding down Alt, what that will do is parametrically consume your geometry and return a parametric spline. So this is a live spline built out of any geometry we feed in. We can update it however we like, but that's looking really good right there. Okay, so let's make this into a simulation. Actually, one change. Right now, all these lines are trying to interconnect in the smartest way they can. I'm going to say, no, don't do that. Just explode. So now every one of these lines is a separate spline. Okay, so now let's add in the rope. So, and you can imagine very meticulously creating this type of thing. But now we can just right-click on that and say simulation rope. And to start out with, let's see, that's a collider. I don't want that to be a collider. Okay, now I said those are all separate little splines. We didn't do any connections yet, so if I hit play, we're going to see all of those just kind of explode away from each other. And then some of them got flung into the mesh. But now let us right-click and add a simulation connector. And right now they're all perfectly on top of each other. Actually, I forgot, we can fix that too. We have a setting called length, and I'll set that to percentage mode and drop that down a couple percent, and you can see the gaps start to appear in between each one. So, okay, handy. Now, with the connectors, I'll say I want to connect to the same object, not other objects. Give me a live update, and you can instantly see connections were made. But because there's so many little splines here, I'm going to up this to a couple extra connections and turn that off, so those should now be interconnected really tightly. And I think that should be all I have to do. Let me hit play, and like instant net set up perfectly around the object. So yeah, instant netting there. That can be fed into this prepared sweep. And yep, let me turn off the geometry. And the sweep should, yeah, okay, caps are off. So yeah, now we've got a nice little Spider-Man logo automatically created from a net. Until Matthias comes out to kick me out, let's go back and take a look at this. We don't have time to walk through the entire thing, but here's a really cool technique. Again, we're going to be using vertex maps in this one. Let me turn this mesh off. So we're back to, here's just a wall on the back and some text, and let me hit NB. You can see it's techniques we've already talked about to generate this type of text. So I made this into, the wall is a collider. This text has cloth on it. And then I belted all of the points onto the wall. So it's completely stuck to the wall. Let me actually clear that out. So just to show you, if I hit play, we should see, hopefully, that the text got pulled to the wall and just stuck there. Like gravity's still on, but you said it got pulled over there. But now I've got a vertex map. And the vertex map is, we got a setup where I've got a couple points selected. So then into this vertex map, I fed, let's just step through this. Here are those selected points, and then there's that same grow technique we already did on the vertex map one. And then there's a random field just to put some variation in. So you'll see that if I hit play, this is going to nice and slowly grow through the letter. Okay, makes sense. And then I created a second vertex map, and what this one is doing is just taking the previous vertex map and inverting it. So yeah, a nice clean inversion of that setup. And because we've got that now, I can go into our belt and change what is being influenced. So if something goes down to 0, it starts getting 0 influence. So all those different connections, every point having a different connection. Let's go and make it look nice. If I hit play, as that vertex map grows, this is going to peel away from the wall. So like, oh my God, like so cool, just letting that peel away. And I mean, just think of all the crazy applications we can do here. And then to push it even further, I was like, okay, what if I did the exact same thing, but I inverted it? So first it's going to all fall, and then it's animating on, and the influence is pulling the text back up again. And this is happening live. Like, this wasn't baked and rewound. This is saying, no, my connection is back again. Let me go to where I'm supposed to be. And then the text gets regrown. So yeah, so much fun. I only got to put this demo together this morning. So we've been playing and experimenting with the soft body stuff since R12. We've had years and years, and we've still been discovering new, fun, powerful things you could do with that. We're only in the first week of this, and we've already got so many cool new things that we can do. So as we move into the future and just keep on, even if nothing changed, if this was the implementation just done, we'd have years and years and years of continuing to come up with crazy new techniques, new ways of doing different motion graphics. The possibilities have opened up so much with this system. So let me just close out all of these files. And almost there. Okay, so thank you, Maxon, for having me out. Thanks, everybody, for coming and watching. As I said, I'm going to have another demo on Wednesday at, I think, 10:30, and I'm going to be taking questions live from the audience, maybe with a focus on some of the new features, because we got all the modeling tools and all the crazy stuff we can do with Remesher, stuff we haven't talked about. But anyway, a reminder again, we've got the 25% off sale just this week, so go to gumroad.com/Rocket Lasso, 25% off all of our plugins, and even a model pack that I put together. So please follow at Rocket Lasso on all the different things, on YouTube, on Twitter, Instagram, everything. And thank you so much for watching.
Big round of applause for Chris. Amazing job. The other presenters actually said, you know what, give him more time. Give him more time. It's fine. It's fine, because you're covering stuff that they wanted to cover anyway. So let me see. Let's see how this. I keep hearing this feedback. Hold on. All right. I think that's good enough. You guys can hear okay, right? All right. All right. So we do have a bunch of questions for Chris from the internet. But guess what? You guys are live. You get priority. Priority here. Question in the front.
You're saying the Z Remesher? Yes. Yes.
You want to just repeat the question?
Yeah, to the extent I heard you, both the CPU and the GPU are running on different machines. I've had them run at different speeds. They're both working great as far as running simulations. In real time on parametric objects. A lot of simulation stuff we can do there is parametric, that. Being able to do the ropes and the connectors and nothing was made editable opens up a lot of possibilities. Once you want to belt something, that's when something has to be made editable. But yeah, everything else, all this integration with the GPU, opening up a lot of new avenues for Cinema 4D. And you combine that with the task manager that's new in S26 as well, so you can open multiple files, multiple CAD files all coming in at the same time, that process being able to be split up, pretty huge.
Roger? So
yes.
So the question was about precise precision tearing. So
yes.
How would you accomplish that?
So I can't build a demo here. Actually, we'll build it in the back, and then I'm sure we'll end up doing it on live streams. But like I said, if you have a vertex map, it's not. If you have something be 100% or 0%, that's not where it's tearing. It's tearing where there's heavy points of contrast. So if you had a letter S, and then you painted one side of it yellow and then the other side of it red, for 0 and 100%, it would want to tear in that particular spot. And what was really cool is when you dragged the vertex map in, you could say, what is the default tearing value, and where is the tearing value when I'm looking at the vertex map? So the rest of it, you could be it's 2,000%. It never wants to tear. But over here, it'll tear at 110%. So you could probably, that would be a really good demo now I think about it. Grab those two different parts and pull them in different directions, and I almost guarantee you'll perfectly travel down that seam. So.
All right. Well then, internet, you're up. Don't worry, I didn't forget about you. Oh, wait, now here we go. Go ahead.
Do I need to do I need to add volume to it first before I do the balloon, or can I just go straight to the cloth material and then add the balloon. You know what I mean?
As long as the geometry. Yeah, I'm sorry.
the-
Yeah, to
the
repeat.
question
Yeah.
again.
It was so if you had like, let's say, flat text and there's no volume to it, can you inflate it? And it's like, well, flat text you can't, but anything you do to give it a volume. So if you put it into like a cloth surface, or if you put it into a solidify, or if you extruded it, or no matter how you get the volume, that would count for the balloon. And you could just put the tag on whatever object said, like, okay, it's a balloon now, or a volume, and then you could balloon it. Yep.
All right, here we go. So these are deformers that we're working with. Can multiple cloth tags be on the same object with different balloon and expansion times will both be applied? Just like you build deformers, can you stack them?
Interesting. I don't think you can. I think you can only have one tag. If you make a second one, it'll just consume the previous one. There can only be one at a time.
Based on the order of operation.
Yeah.
Okay.
But almost everything can be fed a vertex map. So, and then we didn't get into it, but you can belt objects to each other really well as well. So potentially, I wonder if you could belt two things. That probably wouldn't work. Anyway.
So no, use the one tag.
Yeah, use the one tag and vertex maps.
All right, let's see. Does the connector tag only connect to one object, and can the radius be keyframed during the simulation as well? I think you showed it for the spaghetti, or the spaghetti, but you, I guess it was just keyframed. So yes.
Yeah, you can. Well, you can't. It can't form new connections. So the live update is just for building it. So if you had two different strings and they touch each other, you couldn't get them to then stick. That's not a thing. That's a big request I would have, because that would open up even more
Right.
opportunities. But yeah, that you set that up in the beginning.
All right. Can bullet physics and well as the new physics system interact at all? They have an old project or wondering about the simulation system.
I haven't pushed the limits of that. I think they'll see each other, but only as like static geometry essentially. So I'm pretty sure if you did like a rigid body sim and drop a bunch of spheres, and then maybe even cache it, could be a good idea, and then you run some rope simulations, like those rigid bodies will just go crashing through the ropes, but I think the ropes would see the resulting geometry, so that would still work. But you couldn't get the rigid body in a simulation type of way to see like the rope, so they couldn't push against each other. One could see the result of the other.
Okay. Is it possible to make the skin as stiff as cloth or some other type of outer clothing that it can't penetrate?
Can you say the first part again?
So they said, is it possible to make the skin as stiff cloth? So they're
Yeah.
trying to make the skin really, stiff, so you don't have any, type of penetration.
Right. Not so much. It goes to, there's not a lot of very powerful controls right now for stiffness. It's very much like, no, this is supposed to be cloth. You're not supposed to be making very stiff things.
Right.
It's not a
Lot of
rigid body
starch.
system. Yeah. So the most you can do is zero bendiness. And as I showed in the beginning, zero bendiness is still some bendiness. And unlike soft bodies that had a stiffness control that kind of like said, no, keep on returning to your original shape, there's no setting like that. So it mostly goes to balancing having a lower poly count, maybe even doing a low poly proxy on something, because that will make it stiffer. And as you increase your sub steps, that will also stiffen everything up as well.
Last one. This one's for me. With the splines, is there any way besides using an attractor for you to be able to like shrink the spline so it actually feels like it's tightening? So right now, because you would use deflate normally in a volume or on a cloth, but is there anything you can do with the splines to actually shrink them down? So almost like like a Spider-Man type technique where the rope's getting tighter and everything.
Right. There's not currently a length. There's no like rest length right now, so I think they are the size that they are. But I haven't gotten to explore all the way.
Like most spline, maybe.
What pops in my mind immediately would be. It's possible that you could maybe just scale the physical object down, and maybe that would see it, but I don't know.
Interesting. Okay. Things we can try in the back. So, folks, if you have more questions, anything technical, Chris will be back there for another hour. And he does have another presentation on Wednesday. We got you Wednesday. So, Wednesday, check that out, Internet, for more questions. If we didn't get to you, definitely get us to you on Wednesday. Stay tuned, folks. We're going to be up next with Anthony Barr. He's going to be showing you some amazing movie magic. So, stick around for that.